Hello guys, welcome to my YouTube channel Chem Discussion. Now I will be talking about a very useful and important concept in coordination chemistry, which is electroneutrality principle. And this electroneutrality principle is given by Pauling, and by this principle we can demonstrate the stability of a complex. So before going to the topic, we should know some basic things, that what is ligand and how a coordination bond forms and how it works. So what is ligand? Ligand is any species that has a donatable lone pair and that can be donated to a central metal atom or a central positive metal atom. So here ligand which contains a lone pair that is donating to a central metal atom. By that way the coordination bond actually forms. So this is a coordination bond and the complex is called coordination complex. So ligand is such a species that has more electron density and that can be donated, that means donatable electron density should have there, and that can be donated to a central metal atom. Okay, so now the various theory has been proposed to the stability of the complex, and amongst them the Werner theory is very much popular, and one of the most popular theory is Sidgwick principle. So what Sidgwick principle says? Sidgwick principle. Sidgwick principle says that the ligand is donating electron to the metal. By that way it forms actually complex. Now you people think that what is the new here, because now we will see that what is the problem with that theory. In the Sidgwick theory, if we take an example of a complex like cobalt hexammine complex, we can see that the 6 ligand is donating its electron to the central metal atom. By that way they are forming bond. So if you see that every atom is pushing its electron towards central metal atom, so the on the metal atom there is increasing amount of charge. So that means by this theory, in a complex ionic character is being developed, and if a complex are with ionic character, it is very much unstable. So Sidgwick principle fails to demonstrate the stability of the complex. Now the electroneutrality principle plays the role. What electroneutrality principle says? Electroneutrality principle says that in a stable complex, every atom should have a close to zero charge. So that means in a stable complex, every atom should not contain a higher amount of charge. So what does it mean? It means if a complex, suppose if we take the previous example, now this is the previous example, I am drawing the structure over here. What electroneutrality principle says? That after donating the electron to the central metal atom, this bond pair should be attracted towards the more electronegative atom. That means once ligand is giving its electron to the central metal atom, after that, due to its difference in electronegativity, that means the cobalt is more electropositive and nitrogen is more electronegative than the cobalt, the nitrogen is attacking its donated electron pair towards itself. By that way, it is reducing the accumulated charge on the cobalt. So I think I can make the thing more clear, more visible. That means that due to the electronegativity difference of nitrogen and cobalt, because cobalt is a metal which is more electropositive than the main group element, that is nitrogen. So nitrogen is attacking attracting its electron towards itself after donating it to the central metal atom. So by that way, electroneutrality principle works, and it says that if within a metal, within a coordination complex, metal ligand sigma bond is being formed, then there is a tendency to form the metal to ligand pi bond. By that way, actually metal reduces its charge or accumulated electron density, and the complex becomes stable. Now we will discuss two examples and what and how, in that case, how the electroneutrality principle works, we will see. The first example is the demonstration the stability of a resonance structure. So by electroneutrality principle, we can demonstrate that which resonance structure is more stable. Suppose in case of metal carbonyl bond, if we see that metal, after donating the electron from carbonyl to metal, the metal gets negatively charged and the carbonyl portion is positively charged. And one resonance structure we can draw, that this one, where metal to ligand, that means metal to carbonyl pi bonding occurs. That is called actually pi back bonding. We will discuss it another day. By that way, actually metal reducing its electron density. So here, if we see the two resonance structure, we can easily say that which one is more stable. The first one is less stable because in this structure there is a charge separation occurs, but the second structure is more neutral, there is no charge separation. So here, by the electroneutrality principle, we can demonstrate that which resonance structure is more stable and which one is less stable. Now we can take another example, and by that way, where electroneutrality principle demonstrates the stability. Here we are taking 4 complexes, all of our all aluminum complexes, only the ligand is different. And this is hexa-aqua octahedral complex, this is hexaamine octahedral complex. Then we are taking hexafluoro aluminum complex, this is also octahedral complex, and one is aluminum hexa cyano complex. So if we see that which one is more stable and which one is less stable, that means which one is least stable, we want to see that. Here if we see the structure 1 and structure 2, 3 and 4, now structure 1 and structure 3 is stable because here the ligand possesses a strong electronegative atom. The first one is oxygen and the third one is fluorine. So this electronegative atom actually reduces the accumulated charge, so these complexes are stable. Now if we see the number third complex, here actually the in the cyano complex, the cyano complex is very much pi acidic in nature. That means it is very much sensitive to forming pi back bonding with the metal. So that means metal forms pi back bonding with this ligand, so it is pi acidic in nature, and now by that way it is reducing the accumulated charge on the metal. Now come to the second one. Here nitrogen is not too much electronegative, or nor ammonia is much more pi acidic. So that means ammonia actually is not much more fond to form a pi back bonding with a metal. So this complex is least stable. So by that way electroneutrality principle works, and this was a very good topic to discuss. Thanks for today. Subscribe my channel and press the notification